Let us study about beta-cleavage reactions in carbonyl compounds. Beta-cleavage reactions occurs in cyclopropane ketones, that are carbonyl compounds having cyclopropane ring. When carbonyl compound is irradiated by UV light, it undergoes N to pi star transitions and enters singlet excited state S1. Then through intersystem crossing, it enters triplet excited state T1. This excited energy is transferred to beta bond, the bond between alpha carbon and beta carbon. As the beta bond is weak, it cleaves to form 1,3 biradical intermediate. This 1,3 biradical intermediate undergoes 1 to 5 1 to hydrogen shift or 1 to alkyl shift to form products. The formation of 1,3 biradical is the primary process. The 1 to hydrogen shift is the secondary process. Let's consider an example. This is acetyl cyclopropane. This is the cyclopropane ring, and this is the carbonyl group, that is the functional group. This is CH3. So this is acetyl group and this is the cyclopropane ring. So this is acetyl cyclopropane. This is the functional group. C double bond O is the functional group. So adjacent to the carbonyl group is the alpha carbon. Adjacent to it is beta carbon, and this is another beta carbon. So when it is radiated by UV light, the bond between alpha carbon and beta carbon is cleaved to form two radicals. One radical at this carbon atom and another radical at this carbon atom. So this is 1, 2, 3. So 1,3 biradical intermediate is formed. This is CH2, CH2, and this is CH. These are the two radicals. Now this, in the secondary process, this hydrogen may shift to this carbon atom, that is 1 to hydrogen shift, or this hydrogen atom may shift to this carbon radical. This is also 1 to hydrogen shift. So this is A route and this is B route. Let us consider A route. In this, the hydrogen atom here is shifted to this CH2. So a new radical is formed on this carbon atom, and already one radical is there on this carbon atom. These two radicals will join together to form a new bond, as a result of which there is a double bond formed between this carbon atom and this carbon atom. This is the major product in this reaction. Why? Because there is alternating double bonds in this carbonyl compound. This is the double bond followed by a single bond and a double bond. So because of resonance, this product is more stable. So this is the major product. Now let us see the B route. If the hydrogen atom present here is shifted to this carbon atom, If it is shifted here, a new radical is formed on this carbon atom. This radical and this radical, which is already present, will form a new bond here between this CH2 and CH. And as a result of which we get minor product. This carbonyl compound is minor product because this double bond is followed by a single bond and another single bond. So there is no chance of resonance. So this product is less stable. So this is minor product. So as we have seen, the cyclopropane ring gives 1,3 biradical in the primary process, and the 1,3 biradical intermediate undergoes 1,2 hydrogen shift to form two products. One is major product and another is minor product. Let's see another example. This is a carbonyl compound. Now this is one CH3 group attached here, one CH3 group attached here. This is the carbonyl group. This is the functional group. So adjacent to it is alpha carbon, and adjacent to it is a beta carbon, and this is also a beta carbon. So this is the cyclopropane ring. So this carbonyl compound is having a cyclopropane ring. So beta cleavage can occur in this cyclopropane ring. Let us see what happens when it is irradiated by UV light. When it is irradiated by UV light, the bond between alpha carbon and beta carbon undergoes homolytic cleavage to form two radicals. This bond cleaves to form two radicals. One radical on this carbon atom and another radical on this carbon atom. This is the primary process. In the secondary process, this CH3 group, that is the alkyl group, will undergo 1,2 alkyl shift. This is one carbon atom, this is second carbon atom. So this alkyl group will shift from here to here, as a result of which a new radical is formed on this carbon atom, and this alkyl group is attached to this radical. So there is a new radical here. These two radicals, this radical and the radical already formed, will together form a bond, new bond, as a result of which we will get a new bond between these two carbon atoms. This is the only product in this reaction. Let us see some more examples. Now this is a bicycloketone. This is one cyclic form and this is another cyclic form. This is the functional group. This is the alpha carbon and this is the beta carbon and this is another beta carbon. Now when it is irradiated by UV light, this bond can cleave and this bond can also cleave. Let us see what happens when this bond cleaves. When this bond cleaves, two radicals are formed. One radical on this carbon atom and another radical on this carbon atom. As a result of which we get 1, 2, 3. That is 1,3 biradical intermediate is formed. This is the primary process. After this 1,3 biradical will undergo 1,2 hydrogen shift. There is a hydrogen atom present here on this carbon atom. See, the carbon atom which is not having the radical will have the hydrogen atom. This hydrogen atom can shift to this radical. This is A. Or this hydrogen atom can shift to this radical. This is root B. Let us see root A. This hydrogen atom shift to this radical. So as a result of it, we get CH3 here. Already CH2 is there, so one more hydrogen is added, that becomes CH3. As a result of which, a new radical is formed here. This radical and the already present this radical will together form a bond. So we will get a bond between these two carbon atoms. This is a major product because here is the double bond and then there is a single bond and then there is a double bond. So alternating double bonds are present in this compound. So this is major product because of the alternating double bonds, resonance is possible in this compound. So this is more stable. So this becomes major product. Now let us see what happens when the hydrogen atom shifts to this carbon atom, that is B root. When this hydrogen atom shifts to this carbon atom, a new radical is formed here. This new radical and this radical will join together to form a new bond. It is represented in red color. So this is minor product because it is less stable. Why? Because there is a double bond here, then a single bond, then a single bond, then a double bond. So it cannot have resonance. So it is less stable. That is why this is a minor product. Now let us see what happens when this bond cleaves. This alpha carbon and this beta carbon bond cleaves. Now when this bond is cleaved upon irradiation by UV light, we get two radicals, one on this carbon atom and another on this carbon atom. As a result of which, this bond is cleaved. So we get ring expansion. So we number the carbon atoms in order not to confuse. So this is first carbon atom, 2, 3, 4, 5, 6, 7. As a result of cleavage of this bond between these alpha and beta carbon atoms, we get 7-membered cyclic carbonyl compound. If we consider the radicals, this is the first radical, first carbon, second carbon, third carbon. So this is 1,3 biradical intermediate. So this is the primary process. So 1,3 biradical undergoes 1,2 hydrogen shift. Let us see that. So the hydrogen is present on this carbon atom which does not have radical. This hydrogen atom can shift to this radical or to this radical. This is A route. Let us see A route. The hydrogen atom which is present on this 6th carbon atom will go to 7th carbon and it gets attached here. As a result of which a new radical is formed here. This radical and this radical will together join and form a double bond. This is a minor product because there is a double bond here, then a single bond, then a single bond, then a double bond. So it has no chance of resonance. So since it cannot resonate, this is less stable. So this is minor product. Now let us see what happens when the hydrogen atom shifts to this 5th carbon atom, that is B route. When the hydrogen atom shifts from 6th carbon to 5th carbon, get attached here. As a result, we get a radical here, a new radical. This radical and this radical will join together to form a double bond here. as a result of which we get a resonating structure. This is a double bond followed by a single bond, then a double bond. The chance of resonance is there. So this is more stable product. So this becomes major product. Let's see another example of beta cleavage. This is a cyclopropane ring with the substitution on this carbon atom. A phenyl group here and a methyl group here. This is the carbonyl group. This is alpha carbon and this is beta carbon and this is another beta carbon. When it is irradiated by UV light, the bond between oxygen and carbon atom cleaves. This is the beta bond. This is the beta bond and this is also a beta bond. But this bond cleaves more easily because the carbon oxygen bond is weaker than the carbon carbon beta bond. So the carbon oxygen beta bond will cleave to give us two radicals. This is 1, this is 2 and this is 3. So a 1,3 biradical intermediate is formed. Now since there is no carbon atom, hydrogen atoms on this carbon atom, there will be 1,2 alkyl shift. Let us see that. Here on this carbon atom we have phenyl group and methyl group. Phenyl group is a heavier group, so methyl group will shift easily. So only methyl group will undergo 1,2 alkyl shift. So the methyl group will shift from this carbon 1 to second carbon atom. This is the 1,2 alkyl shift. As a result of which we get C6, C5, H6, C double bond O. This oxygen atom has one radical and another new radical is formed here. So these two will join together to form a C double bond O. And this CH will be attached to CH3 and it is attached to C double bond O and CH3. So this is the only product and this is the major product. Although it has no alternating double bonds. Okay. So CH3 group will shift easily than C6H5. So the phenyl group doesn't shift, only methyl group shifts. Now let us see this example. This is another carbonyl compound. This is the carbonyl group with a cyclopropane ring with oxygen, that is epoxide. There is a methyl group here and methyl group here. So since this is the carbonyl group, this is the alpha carbon, this is the beta carbon and this is also beta. But the beta bond, that is the bond between alpha carbon and beta oxygen, will undergo cleavage easily because this bond is weaker than this bond. So carbon carbon bond is stronger than carbon oxygen bond. So this bond will cleave to give us two radicals. One radical on this carbon atom, alpha carbon atom, and one radical on this oxygen atom. As a result of which we get 1, 2, 3. That is 1,3 biradical intermediate is formed. So this is the 1,3 biradical intermediate. Then in the secondary process, 1,2 alkyl shift occurs. There is an alkyl group, that is methyl group on this second carbon atom. This will shift to first carbon atom. This is called 1,2 alkyl shift. So as a result of which This alkyl group will shift to this carbon atom, as a result of which we get a new radical here. This new radical and this radical on the oxygen atom will form a double bond, as a result of which we get O double bond. See, O double bond. This is the product. Let us see. This is the beta cleavage reactions. So we have seen 4-5 examples of beta cleavage reactions. So beta cleavage reaction is consisting of two processes. Primary process, in which 1,3 biradical intermediate is formed, and in the secondary process 1,2 alkyl shift or 1,2 hydrogen shift occurs to give us products. Thanks for watching. In our next video, we shall learn about the differences between Norris 2 reactions and beta cleavage reactions, and if possible, the difference between Norris 1, Norris 2 and beta cleavage reactions. Thanks for watching. Please subscribe, comment and share. Thanks.